Hello all. This is the third part of NumPy. So in this lecture we will see about arithmetic operations with NumPy. Then we will see some universal functions, unary universal functions and binary universal functions. Then we will see some mathematical and statistical methods in NumPy. So first we will see arithmetic operations with NumPy arrays. So I'll first define an array. So I'll use this array. I'm using 1, 2, 3, 4, 5, 6. So this array, if you print this, you can find this is the array. Now we can perform arithmetic operations in this NumPy array. I have already mentioned that this is a matrix. This is like a matrix. So if you want to add two empty arrays, it is very simple. You need not write any for loop and all. So if you want to add ARR with ARR itself, it's very easy. So you can simply use this plus operator and you can add it. Now it is, so you have added 2 ARR. That means 1 plus 1 it is 2, 2 plus 2 it is 4, like that you can add. And similarly, if you want to subtract, it is easy to subtract. You have to replace with minus symbol. So you'll get 0, 0, since you are subtracting this with the same matrix. And similarly for division also, you can perform this division also. You will get 1. So each element, so this is element wise division. Now what happens if you perform multiplication? So multiplication is actually happening element wise multiplication. This is not the ordinary matrix multiplication you have seen. This is element wise multiplication. That is, you will be multiplying ARR, the first element with the first element. So 1 into 1 it is 1, 2 into 2 it is 4, 3 into 3 it is 9, like that it will go on. Okay, so in this way you can perform arithmetic operations. So if you want to perform 2 by ARR, it is possible. So it is each element will be divided by the result will be 2 divided by ARR. That is, each element, we will take each element, then you will perform 2 divided by that element. Okay, so 2 divided by 1 is 1, 2 divided 4 is 1 point, 1 by, so this thing. So in this way you can perform this division. So you can perform division. Then it is also possible to compare also. If you want to compare two arrays, it is also possible. Now I will declare another array, ARR of 2 equal to np dot ARR. Now I will add some values. Now I will take the same values here. So I will use the same values and I will change some of the values so that I can compare this array. So I'll change some of the values. I'll change this to 2 and this to 0 and this to let it be this to 1, this to 5, like that. I'll change some of the values. Okay, now ARR2 is this 1 and ARR is this array. So ARR2 is this now. Now you can compare these two arrays. So if you want to compare whether ARR2 greater than ARR, so element based comparison will be done. So ARR2, it is this array, so 2 greater than 1, it is true, so it will return true. Like that, each element will be compared. Similarly, if you want to compare ARR2 less than ARR, it is also possible. Now ARR2 equal to ARR. So you can compare each element like this. You can do comparison operation also. It is possible with this ND arrays. Next we will see some universal functions. Okay, universal functions. So there are universal binary and unary functions. So unary functions will take only one array. So we will first see some universal unary functions. For that we will use some array. We have an array ARR. Okay, we will take this array. Now universal first one I will do is ARR square root. So if you want to perform square root, it is possible. So you can perform square root like this. So you will, you have to use np dot square root of ARR. So you can get the square root of this array. So each element, so square root of 1 is 1, square root of 2 is 1.414. So you can get, so here it takes only one array. So one empty array is taken. So that is why it is known as universal unary function. Now if you want to calculate a exponential np.exp of ARR, so that is also possible. You will get the exponential value of each one. So exponential of 1 is e raised to 1 is 2.71, like that you will get the exponential values also. So all these are unary functions. I will show some more unary functions. So these are unary functions. There is absolute fact. So compute the absolute value element wise for integer, floating points, or complex values. Then we have C square root. Then there is square. So it is equivalent to ARR exponential of 2. It is possible. Then exponential function we have seen. Then there are different logarithmic functions. This is natural logarithm, base 10 logarithm, base 2 logarithm. This is log 1 plus x. Then we have sine. So it computes the sign of each element. It will return 1 for positive, 0 for 0, or minus 1 for negative. So if you want, you can check that thing. So what we have to do is we will create an array ARR equal to np dot random number of 10. Now if you check this, this is the array A. Now if you want to get sign of that thing, np dot sign of A. So you will get the sign. So first one is positive, that is why it is 1. Second one element is negative, it will return minus 1. Like that you can get the signs. So you can use the sign. Then ceil function is there. Ceil function. So compute the ceiling of each element. That is the smallest integer greater than or equal to. So if you want, you can calculate the ceiling here. So if you want, you can simply calculate. So ceil. So this is a ceil. So 1.71 will become 2, then minus 0.4 will become minus 0, then minus 0.8 will become 1. It is a ceiling, the topmost person. So minus 1.1 will become minus 1, like that you will get the ceiling also. Similarly, a floor function, which will compute the floor of each element, that is the largest integer less than or equal to each element. Then rint is the round elements to the nearest integer, preserving the data type. Then mode function is there, return the fractional and integral parts of array as a separate array. Then isNaN is there, if there are NaN values, not a number value. So in certain cases, when you create this empty array and all, there will be NaN values, NaN. So those are known as not a number values. So it returns a Boolean array indicating whether a value is NaN or not. So if you want to check whether there is NaN and all, you can use this isNaN function. Then isFinite, isInf. We won't be using all these functions. Some of the important functions we may use for some programs and all. Then we have cos, cosH, sin, sinH, tanH. All these functions are there. If you want to calculate the cos of this thing, you can simply calculate np dot cos of this A. So you'll get the cos value of each element. So you can get the cos value of each element. Then like that sine, tan, h, everything is there. Then arc, inverse trigonometric functions are also there. Then you can compute logical NOT. It is equivalent to NOT ARR. So it will take the inverse or the NOT operation of that particular each element. So all these are possible in universal unary functions. So these are all universal unary functions because it takes only a single n-dimensional array. Now we have binary arrays also. Binary universal functions are there. So for that we will have to separate arrays. So we will define. So we will open two different arrays with 10 elements, and we will have one more array. We will name it as B. So we will create two different arrays. Now you can print it and see A is this one and B is this one. So we have two different arrays. Now if you want, so there are some operations on two arrays. So if you want to find the maximum among these two arrays, maximum of np dot maximum of A comma B. So what it will return is, it will compare element wise. So it will compare 0.38 with this one. So the maximum is 0.381. This is negative number. So the maximum is 0.38. So the result will contain max 0.381. Similarly, the second element is compared with the second element. The maximum value will be returned. So similarly, we can have minimum also. Minimum of A comma B. So it will return it will compare those two. It will perform element-wise minimum operation. It will check element-wise, and it will return the minimum of both those arrays. And similarly, we can have add also. If we want to add A and B. So this is element-wise addition. So each element will be added. So first element will be added with the first element. Like this, we can add each element with this element-wise addition. Then the element-wise subtraction, everything is there. I will show some more functions. So these are some of the functions. Add corresponding elements in array. Then subtract is there. Subtract elements in second array from first array. Then multiply is there. Multiply those array elements. Then divide and floor divide is there. Divide or floor divide, it will truncate the remainder part. Then power function is there. If you want to raise elements in first array to powers indicated in second array, so it is possible. So if you want to, we will use the same thing and we will replace it with power. So if we perform power, so you will get the power. So you'll get the power. So this here we have some warning also. Warning is there because there are NaN values are there. NaN values are there. So not a numbers are there because we are trying to get some negative raised to negative or something like that. So there are NaN values. So if you want to check NaN value, then you can use isNaN function and all. So this is power, and like that we have maximum. Maximum is there, element wise maximum, element wise minimum is there. Here f max is there. F max ignores this NaN value. If there is some NaN value, then it will be ignored. If f minimum, it will ignore the NaN value. If two arrays in one array, if there are NaN values, it will ignore those NaN and you will get the maximum. Then there is a mode operator, element wise modular operator is possible. Then copy sign. So it will copy the signs of values in second argument to values in first argument. Then all this comparison is there. Greater than, equal, less equal, not equal. All these operators are there. So we know all these operators. So these are all binary functions because we have two arrays. So we will be comparing these element wise to these two arrays. Then we have logical and logical OR and logical XOR. So if you have studied C and all, we know this and logical OR and logical XOR operators. So all these operators are also there in NumPy. So we will be using some like maximum mode and all. We can use in different programs and all. So that's all about binary functions. Then we will see some mathematical and statistical methods. So these are some of the important things that we used in machine learning and all. So for here, we will create a new array with np.random .randn with some 5, 4 elements. Okay, so let it be like this. Now if you print that, we have print these are the elements of this. Now we have some statistical methods, mathematical and statistical methods. So if you want to compute the mean, of this thing, you can calculate simply by using arr.mean. So if you give arr.mean, it will give the mean value of all this. So this way, or you can use in the previous session we have seen that you can use like this np.mean of arr. So both will give the same result. Either way you can use. Okay, you can either use this way or you can use in this way. So both will compute the mean of these values. Then if you want to calculate the sign, so if you want to calculate the arr.sign r, so it, okay, not sign here. If you want to, stop. So if you want to, we are dealing with arithmetic and statistical methods. So if you want to calculate the sum, so if you want to calculate the sum, you will get the sum of all these elements. So arr.sum. Then we may have to calculate the maximum value, arr.max. And similarly, you can use min also if you want to calculate the min value. So this is max, min, all these can be calculated. So here, mean and sum, we have already seen this mean and sum will usually takes an optional axis argument also, that I will show. So we have already seen mean, ARR of mean. If you simply mention ARR of mean, I'll first print ARR. Now if you just simply calculate ARR of mean, you will get the mean of all these values. So if you want to calculate only the mean of particular axis, so if you want to calculate all the column means, only the column means or only the row means, then you can additionally use an axis argument, axis equal to 1. So you will get 5 means. You will get 5 means because it is calculating based on axis equal to 1. That is the mean of first row, mean of second row, mean of third row, fourth row, and fifth row will be returned. Similarly, if you want to calculate mean based on the columns, you have to give axis equal to 0. So you will get 4 values. So each column mean you will get. And similarly for sum also you can use this thing. So a sum you can use SUM. So you will get the sum. You will get 5 different sums. So 5 different row sum you will get. Similarly, you can get the axis sum of the other thing also. Okay. So then other statistical methods you can calculate is, so I'll ARR is this value. Now, if you want to calculate the standard deviation, so if you want to calculate the standard deviation, you can use std function. You will get the standard deviation the whole element, or if you want to get the access standard deviation, it is also possible. Similarly, you can calculate the variance also. So you have studied statistics, standard deviation and variance. So all these can be calculated by simple NumPy function, NumPy methods, AR or VR. Then if you want to sort, so if you want to sort, so that is also possible. If you want to sort, so I'll create another array a equal to np dot random dot in of some 10 values. So if you want to sort this array, you can use sort function. So for that is sort, a dot sort. So you can simply sort. Now if you print this, it will be sorted order. So it will be in the sorted ascending order. Okay. So you can sort this array. If you can for sorting this, you can use this sort method. Then you have already seen this sort. Then you can, if you want to sort the previous array, so you have this ARR. Now if you want to sort this thing, you can either sort column wise or based on this axis. So if you give ARR, so it will be sorted in this order. So if you check this thing, where is it? Just a minute. So this is ARR. Now if you check, this is almost all elements are sorted. Here if you check this thing, this element, so this has been sorted here. So this has been sorted here. Since we are using sort of 0, so this has been sorted in this column manner. So this has been sorted in this column manner since we have used 0. Similarly, you can use the 1 also. So if you use 1, it will sort in the opposite manner. So if you print this, you can see it is sorting in this row-wise manner. So this is a sort method. So these are the different mathematical and statistical methods that are used in NumPy. So there are other methods also for linear algebra and all. We have different methods for calculating the inverse of a matrix, dot product of a matrix. All those functions are also there. But for the time being, you will learn all these methods. Thank you.